Hello, everyone. Thanks for being here. What a nice way to spend our Thursday evening or mornings, maybe for others. So, and indeed, it's interesting because it's exciting. I guess I'm not joking when I say that it's an exciting way to spend our evenings or mornings, because we're actually discussing today about how the software development lifecycle changes with the rise of new technologies such as generative AI. Now, this is a developer-oriented or engineering-oriented talk, but I'll try to make it as transparent and as clear as possible for everyone attending the event, so that even you are not experienced with artificial intelligence techniques, tools, or technologies, even you're not necessarily writing code, but still working with people that are developers. We are part of the team as a project manager, as a account director, or salesperson. I believe this discussion will still make sense to you, because when we talk about the software development lifecycle and its transformation, we are talking about the future of work for us in the software industry. So you probably hear everywhere on the on the social networks that everything is going to change, that people are going to be replaced, that AI now generating the code, AI does everything for us, and so on. So we are here today actually to deep dive into this and understand, is it really like this? What are the current challenges that we are facing? And which is in a way the state of the art of the current Gen AI technology that we are leveraging in this software development lifecycle. And I like to call this session the code that codes, because for the first time now, as developers, as engineering industry, we are producing a program that actually creates new programs. That's pretty exciting. That's why probably it's shaking the whole industry, and it's so controversial, the topic. On the other hand, there is so much more to discover in this regard. It's not only about AI is going to replace everything, and the revolution is coming tomorrow. It's probably it will happen, but we sooner or later we just need to be cautious with the current limitations, and be always up to date with the current transformations, and understanding that the challenges, the limitations, and the opportunities that are um, popping up together with the rise of the emerging technologies. So on today's agenda, we are going to discuss. We are going to split our talk in three parts. For the beginning, we are trying to understand what's going on actually in the engineering and agentic AI architecture in general. Then we are we are looking a bit on what's going to be built and how, because traditional software is going to be replaced. It's not only about the future of work, the changing approach of developing software, but also the software itself is going to bundle more features in the future. And of course, the last part is how we can survive, or not only survive, but thrive into into a fast-paced transforming world of software as it is today. Now, the software industry has been always changing. It was always under a ongoing fast transformation, but now it's probably happening faster than ever, and that's why this topic is probably so intriguing, and so many communication online are about this. Now, I'll give you some highlights, but we'll come back to this all these all these topics on the agenda and the highlights with some recaps at some point, and we'll even have a quiz prepared for you at the end of the session. So stay with us about 70 minutes probably. It will be a dense and long talk. Probably a lot of information here. You don't need to digest everything in a single hour. But as I mentioned at the beginning, you'll receive both the recording and actually the recording will be posted online on YouTube, but you'll be receiving the slides as well, and follow-up email with some other references and some other materials that you can explore to dive deeper into this. So the key highlights for today is that the new software development lifecycle emerges, and AI basically copilots us people, humans, in every role. We'll see what does it mean and how we are leveraging these AI copilots. On the other hand, we'll explore how business users are empowered now to do more than before, and how this improves the communication, how this improves the way people basically interact their workspaces. Then, of course, developers developers' work is centric because uh, it's so-called shift from builders to orchestrators or to leads, because now the intelligent flows and within the intelligent flows, the developers are more and more oriented on conducting their copilots, on building things rather than building them directly. And this comes with additional challenges, of course, with new emergent challenges. Then we have on the list some practical methodologies for how to augment with AI your delivery within your own software projects, startups, either if you are delivering for clients or for your own product or delivering services. And of course, last but not least, we are going to see some demos and some live use cases, some even some code I prepared for you. So depending on the interest on the audience, we may go deeper or less deeper into that. We'll adapt on the way. So the first part is how we are building software now and, like, let's say in the past 3 years. And I would like to start with this quick view on how actually ChatGPT is used. And there are several hundreds of millions of ChatGPT users, but only a small part of them are software developers. Right? But still, even so, looks like 40% of the queries that are created within ChatGPT, they're actually about software development. So almost half of the discussions with the ChatGPT, people are discussing about code, about engineering, software engineering. The rest is history, society, or other economics, finance topics. People are using it for, I don't know, life advices, understanding general knowledge, and so on. But still, despite a very small amount of, I believe, this like roughly 2% of the users are developers, but still 40% of the content it's is generated on this topic, on software development. So that means developers are using it very heavily, and the main topic that they are addressing, of course, is software development. But that's not only intriguing. This is clear is becoming the AI is actually the main tool for developing further AI and software. And that's probably one of the main tool that we are using in the future to do research as well. Now at Cyclum, we had couple of use cases with our clients, and here are some highlights on how we were able to reduce per use case or per different approach the time for each stage of the software development lifecycle. So for instance, you can see that design was pretty optimized, like 35% in analysis phase, because we are now able to understand in depth very large documents. But still, testing maintenance are also optimized. Probably still there is space for improvement and for more optimization in the way we generate or write consistent code. We only observe only 15% of improved efficiency or increased efficiency in writing the code. Now, of course, we will dive deeper into this, but this is just as a highlight. What's happening on the market today? It's, of course, everyone looks for productivity. So at the beginning, when ChatGPT was released, we had just some task agents which helped us as developers to become enhanced developers. Then immediately tools like Copilot emerged, and only in a matter of months we started building role agents, which generated further leveraged engineer, which now engineers are seen like engineers with steroids, if you like, that are leveraging these role agents to do specific tasks. And here are some tools, some examples for that, which are either assisting engineers or attempting to replace them. And you probably heard about Devin or definitely about Cursor, which is one of the most popular one of the most popular vibe coding tools today. Now, they are either partially replacing what we do as developers, but definitely they are assisting us a lot in doing our work. Now, what's emergent is definitely the outcome agents, which basically tends to convert the engineers into more intent engineers. So then engineers will start probably more and more generating intense prompts and orchestrating different tools such as Lovable, which are building platforms for us. Now, things are not that easy, of course. We are not still there. We cannot create with a single prompt hundreds of hours of consistent and robust work. But still, the speed is not necessarily the key, because now the key today, as per today, is the leverage, right? You need to start understanding how to leverage these tools, because we are basically swimming in an ocean. We have so many tools. So many tools are emerging on weekly basis, if not on monthly, but I think we can safely say on weekly basis, we have so many tools, so many models, so many new technologies, so many products that it's becoming more and more difficult to choose and test them and decide whether this or the other it's a batch for our use cases or our organization. Now, another interesting idea, and I'm just highlighting again the ideas, and then we'll address all of them here, is what does it mean for developers to have so many tools and to have so many copilots at the end of the day, right? And here it's an interesting perspective about copilots in aerospace industry. So you remember probably like back in 70s when copilots were released for the airplanes. Several decades ago, these copilots were released on the aircrafts, and people started asking, "Are we going to still use pilots?" And what do you think it happened? Actually, the demand for pilots, for human pilots, increased, because the number of flights were also increasing, and of course, the scenarios, the business scenarios that existed back then were changing, right? That's probably happening in software development as well. We are now getting more power to build much faster, much more efficient new software. But on the other hand, new use cases and new potential features are emerging. So that creates new challenges and more demand for workforce. Now let's see briefly what's going to be built and how we are starting to building this with AI. So first of all, we had already the legacy approach when we were mostly analyzing text, and with models such as GPT 3.5, we're generating text, we're analyzing either code or documentation with those models. But it didn't last too much, because very quickly we started building and leveraging tools. Now, only months later, reasoning models started were released, such as O3, O4, and those gave us more power to build agents that are actually interacting and are becoming more and more autonomous. So here we are in a current state before future AIs and the current cutting edge layer, where we are using reasoning models, reasoning tools, to either process a lot of knowledge, process vast quantity of information, of data. And on the other hand, we start reasoning against this data at an unprecedented rate or unprecedented speed, and we start understanding more and more of what's in depth there, either in our code or in our documentation. Okay, we have now quick list on new possibilities that are enforcing this shift. So in the past, we had physical files. We are following a specific process, so we can review that file. You will retrieve the information. You will end up by some user will process that file and will take an action. Then, like decades later, we started digitalizing almost everything. Some file specialist roles were transforming or disappearing. Now, the future is that upcoming future is that these digitalized files are going to be more and more processed by agents, and it will be so much transparent for us that we are basically becoming just direct users that are consuming those files. So I think it's enough for the highlights for now. Let's do a quick recap, and I would like to emphasize that a high adoption of AI software engineering may come actually with positive effects because we have so much more capabilities on building new software. Then AI will probably not steal necessarily our jobs, but a person that will leverage that will do. As I mentioned, I'm not sure if you saw this one. We are talking about the code that codes, which is redefining our journey as developer. So what does it mean? Our journey as developer today looks like this. The client comes with a request. They want, I don't know, a circle, right? And they are describing it, but this business analyst needs to transfer that piece of knowledge to the developer, which are transferring it into a code. So this transfer or this translation actually comes with some loss of data, right? So that's how the initial request ends up by being something else at the end of the chain, because the chain sometimes it's so long. There are so many processes that need that are exist in the middle, so many people in the middle, and the result is definitely something we don't necessarily want to produce, right? So here is the high level picture on where we actually are, and I believe everyone here is working with documentation or it's living either in one or more of these realms, if not all, but at least in one of them, right? So you are either working with a lot of documentation, either you are organizing tasks and you are managing the projects and processes, or you are writing the code or reviewing it or approving it and so on. So traditionally speaking, we can safely say that we are living in a loop. Our documentation, it all actually starts with an idea, which is the documentation, right? We write long documents and we say, yeah, this is our idea. It's on the paper now. We'll start implementing it. So based on that documentation, we are starting defining what we call the backlog. Right? Backlog is basically a breakdown of documentation into smaller tasks. Then we are organizing them and we say, now we have a methodology. Let's implement the code. We start to implement the code, of course, and what we notice is that it's actually producing more documentation because code, first of all, requires documentation, requires to be documented so that other people that are coming will understand what we did there. On one hand, on the other hand, code sometimes breaks. And why does it break? It's because we do human errors when we design, when we write the code, when we implement a specific task. Sometimes we are not following best practice because we need to do some trade-offs in terms of I don't know, maybe some trade-offs in terms of quality versus speed because of business pressures. And here we are. Code sometimes breaks, so it generates more documentation, right? So this is how we did it for decades already. So we can safely call it the traditional loop. Before AI, it's the way we actually lived our lives. On daily basis, we were either doing this or that, right? And either the documentation code or the backlog, one of these realm was mostly part of our life. Now the main challenge, if you look deep inside here, is that there is always a need of translation between a realm or the other, especially between the task, the backlog we have here, and translating the code. It's mostly you can reduce the problem of a translation from English or mother tongue to Java or Python or programming language. Insert here any programming language you want, right? So this is the challenge we have, and this translation actually causes so many issues and makes us develop more and more complicated workflows and methodologies so we can do this transformation, we can do this implementation. Let's have a visual look on how these processes are looking now. So we have documentation and backlog realms, so they are somewhere there. We have the code, which is somewhere there as well, right? But you can already see and probably agree that there is always a gap between these two worlds. Like humans, people that do planning are sitting in one room. In most cases, engineers are sitting in the other room, and then they need to gather in teams, in squads, or whatever we choose to call them. They need to do meetings, they need to do gatherings, understand each other, do a lot of communication, and ultimately they will start, I don't know, using different platforms such as email or Slack or uh, sort of messaging platforms, so that they are aligning on their thoughts, right? So after they are aligned, they will start building this documentation, as I mentioned earlier, and backlog. So here our workflow starts looking like a methodology, right? Then we have the backlog, we are writing the code, and then we transform it into documentation. Further, we realize, wait, code breaks, right? So what we need to do is to go back to more meetings, go back to more emails, go back to more communication, and actually decide that, yeah, somewhere the code broke, and we need to do the issue triage, for instance, right? So this issue triage, what does it mean? It generates more tasks, and more tasks go here in the backlog, so we need to reprioritize it. And at the end, we will actually end up by having technical debts. We may have delays, and worst case scenario, we may have scope drifts. Sometimes we're repurposing our scope because the timeline have shifted or because the budget constraints. So we end up by actually creating something different than we initially wanted. So here are the emblematic challenges that we identify. And when I say we, of course, I'm talking about Cyclum in the first place, but on the other hand, I'm talking about our clients, because we are working together with our clients and improving, developing these practices, identifying these challenges. And the main challenges that we identify are that onboarding, it's pretty prolonged. So imagine having someone new in the team. They need to get onboarded with the whole documentation that exists. If they are on engineering side, they need to spend a lot of time understanding what the code base does, probably do some reverse engineering, and that only takes time for them to understand how things are going in that organization. What if they need to start coming up with some ideas? So that needs even more in-depth understanding of the current state. And sometimes new people bring new ideas that are actually shifting the direction of an organization, which might be good or bad. It depends on the situation. But what we can definitely say is that these onboardings take a lot of time. Then role hands-off also are taking time. Context is lost in the transition. So when you pass information from a business analyst to a designer to a developer to a manager, reporting to C-level, C-suite, and so on, a lot of information are actually is actually lost. So this is exposing coming with a lot of risks, and that's affecting sometimes the quality and the speed of the delivery. And in most cases, the winners in the software industry are those that are moving faster and have a better methodology. So basically, what they do is they are improving, they are executing better the communication part. So they are minimizing the gaps in the communication. So then they can build faster, they can work as we traditionally say, as a team, right? As a single team. Now, how do we tackle this? Because we have so many challenges, we have such a complex workflow. So, of course, we start by transforming them with an AI first approach or AI first mindset. What does it mean? You have the teams, you have the same meetings, you have the same communication, same emails. You cannot escape that, right? Maybe you don't want to because the team bonding is still important. But what you actually want to do is to have an agent that is assisting you on every single task, especially with the translation part. You don't want anymore to translate code to English or English to code. You don't want anymore to translate documents to design and design to code and spend so much time on synchronizing people. You need that everyone to be on the same page, and you need to do this now, today, right? And you need someone available and very knowledgeable that is able to help you in this regard. And this is the specialized agents, right? Here. So basically, the AI first mindset consists in having agents that are proxying every single interaction of us as human with these three realms. We don't go directly to documentation anymore. We don't read documentation anymore traditionally, or maybe we have like a quick read like briefly, but now we have the capability to ask questions within that document rather than reading entirely. We have the capability to summarize it, right? And there are a lot of new um, items in our processes that are now improving. So let's see a few examples of them. What can we improve if we start proxying every single of our interaction with these three realms, with documentation, backlog, and code? We can start building summaries, right? So probably every person here used ChatGPT at some point or an alternative such as Gemini and loaded some document and summarized them. Imagine you have hundreds of pages of documents, which happens very often. Imagine you have thousands of them, right? But actually, what you want is to summarize them. What you don't want is to lose the context. You are summarizing them once, then 3 months later, when you come back there, the conversation is not there anymore. You need to reconstruct it, right? Sometimes you are even losing the main point, or you may lose even the whole narrative because the conversation becomes too long and because these large language models have limited context, right? So what you actually need to do is to build a system that helps you summarizing this and having a holistic view on all documents so that everyone has a consistent view on the summaries. It's not only about enabling everyone in the organization to summarize documents, but it's about providing to everyone the same quality and potentially the same perspective of these summaries so that you will also not spend a lot of energy on building the summaries because you build them once, you are caching them, you distribute to everyone. On the other hand, you don't have you minimize the risk of losing the context because of the context window limitation of these agents. Now, what else? You can, of course, convert these summaries into actions, and then the actions can become later tasks, right? So you can automatically take a long document, process it, start identifying some actions there, and building tasks out of them, even estimate them. And why estimation is important here, and why we couldn't do this before? Because in order to estimate something, you need to understand the current state of a system, right? In order to estimate how complicated or how easy is to change, add a new feature within a software, you need to know what's the current state and what's the complexity of the task, right? So that it's not only about looking at the task and generally giving an opinion of how long would that take to be implemented, but it's about understanding the rest of the rest of the system and the rest of the tasks that exist there in the QE and the rest of the documentation that includes, that contains the requirements. More than that, think about having issues, right? So issue triage is a process that happens on bi-weekly basis, at least in every single organization that develop software. So having this bi-monthly or even monthly, let's say, takes a lot of time. So you need to, first of all, understand the issue. And it's not only about technical opinion on that. The issue might be bigger or smaller, depending on what business view is on that. Of course, complexity does not directly influence time, Olina, but complexity is one relevant metric. It's one definitely one of the metrics that are impacting this, right? Now, that's specifically why I'm emphasizing it's not only about complexity of the task. Otherwise, you could simply look at the task and estimate it, right? Actually, it's not enough because you need to understand the whole state of the system. Maybe you need to implement a complex task, but it's already 75% done because someone else worked before on that. So having a holistic view on the whole backlog and documentation and even the code base, it's important so you can do estimates. So all of them are actually interconnected. Now, triaging issues it's again a business decision. It's not only some developers saying, yeah, this is a big bug here. We need to fix it and it will take 2 weeks. It's not only about that. Of course, it's about prioritizing it into our um, business strategy, right? And prioritizing it impacts the whole timeline, impacts the whole budget, impacts the whole organization, the availability of the people, and so on. So we need to be assisted in that because a single human mind cannot comprehend everything. That's why we have specialized people for specialized use cases. Business analysts versus developers. They are all specialized on different tasks. But an agent now can be specialized in mostly everything. And that's super powerful. That's how we need to leverage them. When it comes to writing code, on the other hand, we have, of course, generation of code. Now it may look interesting, like interestingly easy from developer community perspective that code generation comes by default. LLMs are now able to generate code. But again, it's not only about this, because when you generate code, you need to make sure that code is consistent with whatever else you generated there. You need, of course, to ensure some quality metrics, but generating consistent code with the existing logic by being aware of the requirements is very difficult. And one of our main use case is because it's related to uh, a client that has 70 plus repositories. So when we generate some of the code in some of the microservices, we need to be aware of what the other parts of the code do. So that's complex because whoever in the history of software development in the past, I don't know, 7-8 decades, who looked on the other code base and analyzed what would be the impact of my commit, my pull request now in another product. Rarely we did that, and for that we had other specialized people such as enterprise architects, solution architects, system architects, integration architects, and so on. So for that, for each of these challenges, we started developing more and more specialized teams and more methodologies so that it will adapt the interaction between people on one hand. On the other hand, we created more interaction. Always, the more you introduce new roles, the more you create new challenges because of more communication interaction and more information loss along the way. So agents can simply find shortcuts for us. And when I say find, actually, it's not them finding, it's us programming them to do that. And we'll discuss in a few minutes how we actually program them. Right now, what else can agents do for us is on the architectural side, is prototyping the architecture. Now, prototyping the architecture is, of course, something that we did for a long time, but the challenge again here is that no single brain or person can comprehend a large code base. And I think most of you here work with code bases that are up to 10 million lines of code, or maybe not a single code base, but maybe 50, 70 repositories that are impacting each other to some extent, and they have millions of, even more than that. Even having 1 million lines of code, if you want to read the whole code base out loud without understanding anything, just read it 24/7 without any break, not even breathing, not even drinking water, it will still take you 1 month. So only reading that, not to mention understanding everything there. So when you need to prototype an architecture, you need first, of course, to understand what's already there. So that's how error starts emerging, because no one actually is able to do that. But agents can help us in this regard. The problem is neither human nor agents have the capacity to actually process millions of lines of code. So we need to deal with this problem now. As a software engineers, that's what it means. That's what it means to start orchestrating the agents. We actually start playing with their context window. We need to understand how to divide the content that is analyzed in smaller parts, and we need to, despite we do not have a full understanding of those parts, we still need to have a good intuition on how they will be used by the agents, so that the agents will have a good understanding of them. Wow, what's this? These are new challenges. They never existed. And in the past 2-3 years, so many methodologies developed. None of them are perfect yet, because everything in terms of approach and in terms of this software development lifecycle approach is actually new. Right? We never thought before that we actually wanted to orchestrate some software for us that is processing other software, understanding other software. We never did it. The most we did in this regard, it was having some people that we were asking them to do some tasks. So we delegated some of the efforts to the people. That made us more technical leads than developers. So what's the challenge actually now is that most developers will need to become, to some extent, technical leads. Technical leads not of other humans, but of other agents. And that means this is actually the real challenge, because the engineer should, the traditional engineer should have this leap from a developer, from a programmer, engineer, whatever. I don't want like now to cause terminology confusion, but let's say from engineer to technical lead, because they are orchestrating more and more agents, and they need to think for them, and for to be accountable for what they do, and to think for their limitations. So in this context, of course, the main question pops on the screen: how to survive and thrive in the new software development lifecycle. And for that, we identified mostly two major pillars. So the first one is the accelerated understanding. What does it mean? It means that we need to start leveraging documentation research, clarification of specifications, structuring the context, summarizing meetings, identifying gaps within the potential like documents that we are analyzing, understanding more and more knowledge, finding things semantically, not necessarily lexically as we did before, and of course the understanding of the whole big picture and the technical landscape. And I would like, maybe all of them are pretty clear, like by default are self-explanatory, but I would like to stop a bit on this gap identification. Think about having some requirements, some documents that tells you need to build this product, right? We were never able to detect within large documents contradictions or missing details, right? Or some gaps. Maybe there are gaps in the logic. Maybe there were scenarios that were never written anywhere in the documentation. Of course, developers use to generate their own part of the code. They do their own tasks. If it works, it works. We have integration tests, right, that are checking if these parts are working together. But we never know the big picture. Not even architects, or I don't know, business analysts, or never. Sometimes we exactly, we don't have documentation at all. This is also true, right? But we still have these discussions. We still have a form of communication. But no one will tell you if you have gaps or not. And actually, it's not only in software development lifecycle. Think about gap analysis in very large documents, such as religious documents, right? So we are spending not centuries, millennia on controversies on some books, right? Because actually no one was able to fully understand profoundly everything there and potentially identify some contradictions. This is what actually is the essence of the controversy on most books. I'm not talking only about religious now, even scientific books, right? That's why we do peer review, because we want to identify these gaps. It was always about this. But in software development, lifecycle is more than everywhere, because we do this on daily basis, and it's so much brain intense activity to find this. It demands having the whole picture, the big picture for everything. And the primary roles that are impacted, of course, are architects, are business analysts, owners of the developers of the products, or specific researchers, managers, and so on. Now, of course, we have LLMs. We can do all of this. It's important first to identify what are the opportunities, and then to start doing them. How to do them? Coming soon. Now, accelerated delivery is the other part of, after you have the full understanding, you need developers at work, you need orchestrators, scrum masters, like program managers, project managers, technical writers that are actually making things happen. Like, but more than ever, you can now generate this backlog and estimate it. You can make sure you're either programming or natural language is polished now. You don't need to spend a lot of time on this if you're writing reports, or if you write the code or comment the code or analyze the code, review the code, approve the code, check for feasibility even, or prioritize some potential issues. You can all do them all automatically, and you can do them all mostly with LLMs. But more than that, it's actually you need to start building some tools that are automating these processes. Because these are the new challenges. It's not only about leveraging these LLMs per se, but about building the right tools or adapting the right tools to do that. So more than this, there are some novel use cases, things that were never possible before GenAI, such as generating synthetic data or ideation by coding. My favorite one is about generating test scenarios, because we were always thinking about testing QA in software, about testing the code. Does it work or not? Is the feature implemented or not? But we were never thinking about testing the requirements, right? Now we can do even that. And let's see some other examples. Some other examples are, for instance, architecture as code. What does it mean? You have millions of lines of code. You have someone new onboarding within your project. They need to understand these millions of lines of code, and they need to spend a lot of time on it, right? But by leveraging AI agents and specific tools, you can start processing that and generate this, which is a diagram, which behind this diagram has a mermaid diagram. It's a text format, and this text format, it's better, it's understandable, it's better understood by the large language models, so that in the future, when a developer, when the architect will start reading or building the platform, they will have this visual picture in their mind. On the other hand, the LLMs will not start just blindly generating code. They are referencing this diagram as well, but just in text format, because mermaid diagram means text format that can be rendered like this. And I will show you an example. Now, another use case is vibe coding and ideation. What does it mean? Imagine you go to a session, you need to prepare for that session, and the main challenge is that you need to put your ideas in order and then start explaining to others and make sure they pay attention to whatever you try to explain them. Sometimes it takes hours. Most of the cases you are losing their attention, because people don't have an unlimited attention span as well, right? So the ideation, it's the good part, that basically it combines the designing something with writing code and also talking in natural language, so that every product owner now, for instance, can start by using a prompt, generating something that looks very real and clickable, and they can go to a session much more prepared and um, present to the others their idea in a much more visual and interactive way. So that's definitely something fundamentally changing from now. People will probably sooner or later start giving up on just talking or sending large pieces of documents. They are starting more and more interacting this way, presenting ideas visually and presenting idea interactively, because this becomes more and more accessible. So these are, again, some use cases that were never possible before Gen AI. But now, with all these new possibilities, we need to see what is next, the role of software engineers. How are engineers actually affected, or what was the leverage that they now have? So I will give you one real life example of Anthropic trying to implement an agent that handles a vending machine. So if you are not familiar with this, you can search on Google Anthropic Project Vend. So this model, this agent actually was tasked to basically handle the whole vending machine and take real money, deliver real products, and then order for more products and the whole life cycle. And it did it decently, not necessarily successfully, but decently, until a point here when it was tricked by someone else and it started also hallucinating absolutely randomly. No one actually understood what's happened. But then the whole performance and the net worth definitely dropped, right? So the key takeaway from here is this is a good study and a good proof that agents and LLMs are still not reliable. It's not like humans are 100% reliable, of course, but they also have their own weaknesses, right? They are still unreliable and unpredictable. At least maybe humans are a bit more predictable, or we develop so many methodologies to prevent unpredictability in humans. In machines, we are still working on that. That's for sure, right? But here is where the AI engineers will have definitely a role in the future, because someone needs to handle that, right? On the other hand, let's look at some comparisons between how human mind and AI works. So, for instance, and here is a long list, of course, and you'll get the slides. But I would like to insist on maybe two of the items here. So, except of ethical reasoning and emotion, which again, it's not universally true in for all humans. But what's the true differentiator? I believe it's the inference, the way we do inference and the way we do the learning, because humans, because of biology, because of billions of years of evolution, or because of optimization, natural optimization, are able to both reproduce things from memory and also learn new things with about the same amount of energy. So you can say that if you eat now a banana, you can still function for about 6 hours pretty well, right? Which is not true for AI models. They need a lot of energy, so they are very, very inefficient when it comes to energy consumption on one hand. On the other hand, you are training them once and then you are deploying them and that's it. It's very hard to retrain them. It's very hard for them to learn new things. It's very time and energy consuming. So from this perspective, human mind has still an edge. When it comes to processing large amount of data, of course, machines are superior, but when it comes to learning speed, there is no doubt at this level. So here is one of the main limitation that we need to deal with. And of course, the context window, the thing that they are not able to process unlimited information as we are not as well, right? But are different thresholds, let's say. Now, I think with this we talked a lot. Just for your information, we had like we have scheduled 90 minutes for this session. We spend about 60 minutes on overviewing and understanding deeply what's happening, what are the challenges. Now, I would like the next 15 minutes to get a bit more hands-on, to show some more practical things, maybe to look on some diagrams and some code. And then the last 15 minutes we'll spend on a Q&A and free discussion. So how do we start even going hands-on when it comes to start building new projects? So we go to new organizations, we start working with, I don't know, a new client, a new organization, where we are the new organization that are starting building things. We still need to understand first what is the degree of the adoption of AI capabilities in our organization. And we started building this framework, which is called AI adoption metric, which basically measures what organization actually have within their processes or within their software development lifecycle. Now, when it comes to software development lifecycle, there are different categories, such as architecture, such as developing code, designing, doing Q&A, monitoring and operation. Of course, this is an oversimplification diagram, because in reality, things are much more complicated. But here are the main use cases that we are looking for, and here are the ways that we are assigning for them, so that we can understand, yeah, this architecture generation or this design validation is important for the organization, so we can say, yes, that organization is AI enabled or not. Now, this, based on the weights here and on a scale from 1 to 5, depending on the state of the adoption of that project or of that organization, gives us a score per layer, which means the software development lifecycle. In other words, is how much that organization actually leverages AI in daily processes of writing the code, right? More than that, there are other matrices for practices. So we are measuring how much organizations are leveraging AI in their documenting or documentation processes, in backlog, in collaboration, and so on. And further on is also the enablement part. I mean, the things that comes additionally, but still enables the good work and the good practices in terms of AI adoption, and leveraging and integrating AI within the scale of the whole organization. And that means either security, either educational program, or innovation capacity, and so on. So after we know this, right, let's say we start from scratch, we don't have any of this, we'll need to start building agents. And here is a diagram on how a framework of an agent would look like, right? So in order to build an agent, you will need to build first a data source. And here you use a data source. It's either Git, it's either Google Drive, it's either Atlassian. I put them all together because it doesn't matter if it's in natural language, if it's like English documentation in Atlassian or in Google Drive, or it's in JavaScript, right? In Git. Usually in Git we store code. It's not mandatory, but this is the best practice, of course. And in Atlassian we store documents, right? So we need to process them all and pass them to an ingestion layer. This ingestion layer can bring to a scraper documents or information from outside of the organization, or scrape internally. Although internally we have APIs, so we are connecting to these data sources through some specific interfaces. We pass them through a chunking layer, which means we are splitting data in smaller parts, because we don't want LLMs to deal with thousands of pages of documents, because they cannot, right? So we need to chunk them. We are maybe augmenting the knowledge, we are preparing the data, we are summarizing it, and finally it ends up in a knowledge base. This knowledge base should be, of course, related and linked to a persistence layer, where we are saving things persistently, right? Like such as a database. But also they need support from a vector store, from a graph database, because we need to start doing semantic search, not only lexical traditionally. Then the users should be also linked to the knowledge base, because when we look through that knowledge base, we need to make sure, yes, this user has access to this resource. Otherwise, we decline the access on that information, so that the agent will not potentially respond on any private data from inside there. This is the agentic core. Agentic core basically has an orchestrator and has some specific modules. And you may wonder, what does this module look like, right? What's a reflection module? What's an action module? What is a behavioral enforcement module? And I will give you an example now. Maybe let's look a bit in the code, right? So here we have our blank screen for now, right? And we have our code and our services layer. Where in service we have this agent AI. The agent AI is our orchestrator, basically, right? And the orchestrator looks as simple as that. You have, I mean, you can do it unlimitedly complex, but basically you have the agent AI, which has, of course, some attributes here within the class, but the important ones are these: the memory, the reasoning, and the topic manager. Let's choose one of them randomly. Let's say we choose, or maybe two. Let's choose the reasoning part. So the reasoning looks like this. The reasoning actually it's another class which has some other methods. But what's particular to these methods is that this, I'm sorry. What particular to these methods is that they are not exclusively written in Python or in a programming language as you would expect. Part of them is written in English. It's a prompt, because this is going to be executed by an LLM, and the LLM will do will generate the output, which is either true or false. This is how we start doing reasoning, right? What about the memory? So the memory, it's of course storing persistently some data on one hand. On the other hand, of course, we can have some flags such as store the data or do that persistently, right? But on the other hand, you need to do this in a history layer, which basically is just a QE of your previous messages. And here is another parallel between the human mind and agents. For human mind, this history basically is the whole knowledge base. Think about it. Everything you ever talked with, or you talked or you listened, it's your life, right? That's all you know. Maybe you read something, you read or you look at some images, but it's still the interaction history. But agent doesn't work like this, because within the agents we can inject through a backdoor some different knowledge, and this is the leverage that they have actually, right? On the other hand, agents needs this persistent layer to be handled separately. The history needs to be handled separately, and there are so many pieces that need orchestration. While for human mind, this is not necessarily true, because they are all the same. And that's how the energy consumption is lower on one hand. On the other hand, that's how we have different leverage. We have definitely a leverage when it comes to reasoning and comprehending like very complex contexts and large pictures, right? So this history basically is just another list of messages, but what's particular to them is that they need to be classified by topics, right? And we have also something that it's called topic domain manager and topic manager. And the topic manager basically helps us identifying to which topic belongs a specific item in the history. So when we are retrieving the history, we are not retrieving the whole history, because we don't want to exceed the context window. And this is how you basically avoid processing too much with the agents and exceeding their context window. Now you will say, yeah, it's a lot, of course, right? And it's probably a huge leap, and that's exactly what I wanted, to jump directly from this theoretical explanation to the code, because now we don't need to spend that much time on understanding the code, since we have assistants such as Cody or such as Copilot or Kodo and so on, which we can ask, for instance, things like build me a mermaid diagram and help me understand how this code base looks like, right? So the prompt is here, and I was asking to generate for the whole code base, for the whole repository, a mermaid diagram. And it looks like this. Now it's actually empty. So I generated it here. Let me see. I believe here or here. Yeah. So if I apply this, yeah, there you go. So now we have the code version of the diagram, which is friendly for the LLM. So next, when I need to add a new feature there, the LLM will go look up into this and will continue building it. But this diagram, it's friendly for us, right? It's humans, because we can see here, which is the API gateway front-end layer orchestration, right? And it basically looks like actually like this, right? You see the orchestration here, and all these items, they are all there as well. They're all here on this diagram. But this time I did not spend time on building the diagram, because the LLM did that for me, right? You need to use the right tool, and one of the tools that I was using is able to scan multiple repositories. This is called source graph, but there are alternatives as well. Here you will also see in the diagram, you will also see the LLM router. So what does it mean? You need, for different requests, you need to use different models, because some of them are good on something, some others are good on other things. So if you zoom in into this LLM router, you will see something like this. You either go and do inference in managed cloud services, or either pull your models from auto repository through Hugging Face and bring them through Llama CPP or different LLM server. And they all have their pros and cons. For instance, Llama is very friendly for users, but it's not that performant as Llama CPP, right? Because they're using different layers on the operating system to do the inference. So we basically need to rely on all of this and build robustly our infrastructure, so that we will have both this model implemented consistently, protecting the data, and also routing to the right LLM. And here is an example of how we did it for some use cases at enterprise level. So we basically had this documentation realm, the backlog and collaboration realm, and the code realm, and they are all interconnected through a data ingestion pipeline to the knowledge base, and they are all talking with the agent modules. And on top of that, we are also leveraging this agentic fleet. What does it mean, agentic fleet? It's basically just another class with different methods which serves different purpose, just because we tell them in plain English. And the way we orchestrate this gives us the agentic core framework. Now, okay, interesting and probably complex diagrams. You don't need necessarily to digest them all now. Of course, you can have a look on them later, but this is a good starting point, so you can start diving deeper into this, either discussing with some models or looking into like on Google for some more documentation. We of course will send some follow-up communication on this as well. Now, here are some tools that we are leveraging, because you don't necessarily need to build all this stuff, right? There are tools that are helping you to analyze the knowledge. There are tools that are helping you to do this code assistant part. And we try to classify all the tools in these 5 major categories. Because it's clear we need to make sure some of them have different purpose than others, right? Now, here is also a view on classifying them, but by using the logos, maybe it's a bit more visual. And some of these tools, you probably already know them. But if you don't, my next suggestion is go look into them. And most of them, with some 2 or 3 exceptions, most of them are free, right? So you can test them, or at least have a free trial on them, right? Here is another view on the tools that we are using. Because again, you don't need to develop all these add-ons, but you still need to understand how they work, because you will be always in a buy versus build situation. So for discover phase, we use tools like SourceGraph, ChatGPT, Notebook LM, right? In order to develop things, we use Copilot. Also SourceGraph again, NA10 for automation. But the same thing with different instance we can achieve with the agentic framework that I earlier presented, because the repurposing it's pretty easy and it can be done in natural language. Um, I believe there is one more thing that we need to look into, and this is the way we check the quality. And I mentioned earlier that actually we were always thinking on testing the quality by testing the code, but never by testing the requirements itself. Now, another considerant is that when we talk about data privacy, we don't only need to think about storing data uh, anywhere in cloud or where the data is stored, like traditionally, but we always need to think what does our agent holds in their conversation history, because you may want to withdraw the permissions to some documents at some point for someone, for some users, but they still have the conversation history. So for humans, this is not possible, but for agents, it is. You can erase basically their memory from their history, from their conversation history. This is the new realm of data privacy and the new dimension of data privacy that we are entering these days because of the Gen AI. Now, whenever you use one of these tools in the future, make sure you are cautious about the way they handle your data, the way they store it, and the way they train, whether they train or not their models against your data. And if you're not sure how that works, go back again to this diagram and look again on how these agents are built and at high level where they could potentially store the data, because most of them are done in this way. This is not the only way, but this is a design pattern for sure. Just wanted to show you how this works in real life, right? Because we have this app there. We build the agent. We have some specific services such as memory service, reasoning service, right? Domain manager. We have some integrations here, and main integrations are with LLM, right? So how does it look from our perspective? If you write it in code, it looks like this. You have an LLM inference module, which basically has a handler. Sorry, where are the handlers? Here. Here. So they have the handlers and they are pointing to different models, right? Let's say they point to Olama or they point to an interface to OpenAI. And it looks like this. It has this call to OpenAI, while for Olama or for Gemini, the call looks different, right? So the call it looks like this because different models accept and return different outputs, of course, right? Gemini has some leverages in this regard because you can set directly here, you can set the harm category, for instance, hate speech. You can limit the hate speech, but just configuring the flag. Now, when you want to work with multiple LLMs and route your request through one or the other, of course, you need to also build this kind of interface and create an abstract layer that is giving you either this behavior or the other behavior, or because of the behavior, because of the type of data, you want to use one model or the other, right? But what else you can use, like as a product, for instance, you can use a light LLM, which looks like this, and it basically does the same thing, right? It gives you guardrails, it gives you budgets, rate limiting, and so on. So basically, it takes the prompts. It's an interesting tool. You should try it. And it decides where to go, to which LLM to go, depending on the case. Right. We do this here as well. And how does it look on the real life implementation? So it looks like, oh, actually, I don't need to turn this on. I have it here. One sec. So this is the GUI that we are leveraging. It is called Cyclum Agentic AI framework. Actually, this is acting as a model. So the model, for instance, can be changed. You can even work with select them and work with them in parallel. Let's say we want to use GPT-4o mini and our model, and we want to ask something. Tell me something about current project. Of course, GPT doesn't know, it's not aware of the project, but our agent is, because deep inside here we have, give me a sec. Yeah. So here it's reasoning, right? It's passing through the whole life cycle that we've seen in the diagram. And somewhere here we have the knowledge, agent knowledge, which tells us details about the project, right? This is acting actually very similar to a model, but it responds as a model, but it's aware of all the data within our organization. Now I store this for the POC in a JSON file, but in reality it can be here anything. It can be a vector database, it can be a graph database, and so on. So here you'll see the different answers. So GPT will say, I'm not able to access real-time information, while Cyclum Agentic Framework will say, the project detail, the BRD, blah, 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 right? It even gives some random names, which are not random, are of course extracting from the documentation. What is particular to this, and I'm coming now back to my diagram. Here is another agent that I enjoy the most, is this behavioral enforcement, because you will ask, how can you trust it? So here is how can you trust it. You can go to the config, and you have here the behavior agent configuration. And instead of having a professional, you can say poetic. Instead of concise, you can say lyrical and imaginative, right? And instead of English, you can say, I don't know, German, whatever, right? So it runs at this is automatically updated at runtime, so you don't need to do anything to change this. One sec, and I need to go back to my agent and say something like, tell me something about our project again. And it will give it a moment, and let's see what happens. Okay, and here is the result. We have a poem with the same answer, but it's in German, right? Because we control the behavior, we control the knowledge, we have guardrails, and we have the whole orchestration. And the reasoning behind it, it looks like this, right? It has like step-by-step executing all these parts that you've seen there into should I load the slide here, right? Into the diagram. This is how data flows, and these are the real life results. Why I chose this GUI is because it's very familiar to what ChatGPT looks like, so everyone in our organization can get familiar with it. It's an open web UI based GUI. You also have a lot of fine tuning parameters here. So you can, for instance, set the seeds, you can set the sequence top parameters, the top K, and so on. So you can influence even the model here. It gives you a very large degree of customization. So it's one of the best solutions you can use to build something internally and leverage your knowledge privately and decide which are the LLMs that we are using. And this way you can either choose to generate tasks, to estimate them, to process, generate diagrams, to understand them, process summaries of the meetings, and so on. And last but not least, we have the FAQ part. Okay, so I think some of them we already discussed. I vibe code is something, it's not production ready. Of course it's not. This is good for ideation. How do I integrate AI into my existing SDLC? So I think the main answer is that identify what are the tasks that are taking more time, like communication tasks. this is the main idea. On the other hand, you need actually to focus on building an entity that knows everything about the organization while still keep secure the data and distribute it to the users as they have the permission to access that data, right? And a lot more. You can. I think there are still some questions in the chat here, but I believe we can still discuss about them. Main takeaways is that AI definitely amplified productivity. There are novel use cases, which I've seen you already know them because you answered well on the quiz. There are definitely new challenges and new risks emerges into the software development world. And of course, the thriving teams invest into education and understanding all this stuff. So the takeaway, it is estimated as a call to action, sorry, it's estimated that by 2026, next year, 40% of the enterprises will actually use AI add-ons. Now it's only 5% or something like that. So we have only like the technical leads have about 6 months to define a strategy and focus on these success pillars: people and culture, governance, architecture, and data, and make sure the distance between all this is shrinks with the help of agentic AI. Now, thank you for your attention. I think we spent almost 90 minutes. I think we started like 5 minutes later. Maybe we can like have time for one or more or two more questions.
Thanks for the wonderful session.
Thank.
I just need to discuss one query. Right now, I'm working on different AI agents. So we have made multiple automations for companies to integrate in various operations like sales, recruitment, and marketing. But the problem I'm facing right now is that the data security which the clients demand to us for their company and having trust in our AI agents in deploying these with their company status. So we face a lot of issues regarding the data security. So can you suggest how we can make us assured for those companies to trust in our AI agents for the data security?
Yeah, absolutely. So I believe when we talk about data security, we are actually looking at three things. And interesting, I had a call this morning with a client on specifically this topic, which is like secure AI, right? It's AI in security. It's one topic. We're not discussing about that, but secure AI is the other one which we want to address, and that's about how you actually leverage your LLMs so that all those requests are not stored anywhere and they are not used by any organization to train your data. This is one of the question, right? One of the concern. And the reason this is concerning is because LLMs can learn from our information, but not by default. They are they are statically trained, and that's it, right? So all you need to do is to focus on choosing a cloud services, managed cloud services such as AWS Bedrock or Azure AI Studio, right? They provide models, and they also make sure your data is stored there. Even now, all organizations have this data in cloud in different repositories, but they are encrypted. So you don't care about that. You don't care if they actually have your data. All you care is that they don't keep decrypted data of the conversation, which doesn't happen at that scale. Still, if you want to make sure, you need to build your own router here, and that router needs to decide based on keywords, based on any algorithm you prefer, whether the request goes here or goes somewhere, I don't know, like calling an REST API and do the inference locally or on some on-prem environment. Here is an example. You have LM Studio, right? You can easily deploy an LLM within your local machine. And I have now LM Studio with Gemma 3 12 billion, and I can ask it anything, like tell me something about Greece. Everything I'm discussing here runs entirely locally, right? So nothing goes, I think, can you still hear me?
Yeah, but it's scary.
Yes, I think my laptop froze. Okay, now it's fine. So this works. Yeah, probably that's why it froze. because it's consuming 95% of memory from. It's lagging a bit, right? But it's consuming a lot of memory, but it runs entirely locally with a pretty powerful model. It's not as powerful as Cloud or GPT, but still is powerful enough so that you can check at least if your data is potentially harmful or potentially extremely confidential. So you are not sharing it with anyone else outside of the organization, right? So this is one thing. The other thing is make sure when you design your architecture, this history layer, this memory here doesn't store the data more than a specific amount of time. No one is able to access that data in plain text, or make sure if they lose some access on these data sources, they will lose also access in the memory, right? Because now we have a different dimension of storing data. So that's how data privacy transforms. This is a very complex topic, and I believe clients do not look only on this kind of technical explanation. They also rely on trusting the people they are talking with, because this has a lot of intricacies and a lot of like hidden challenges, which of course are relevant to both providers and to both clients, but clients need to make sure that you have tons of experience with that so you can handle it. You can handle all the new challenges that are emerging, right? So my suggestion is take a look on how you build your own LLM router very robustly. Learn a lot about handling memory and encrypting data, decrypting memory, and managing the topics. And the third point would be make sure you have a very solid pitch in front of your clients, because you need to earn their trust as well. It's not only about showcasing some of the existing tools that are promising privacy. It's not only about that. It's also about how you architect the whole ecosystem.